Hi, this is Fazana again. Welcome to part 2. Now you've learned the basic concepts of probabilities. We'll look at questions where you pick a counter and replace it before you pick another. Okay, so the key word here is replaced. Remember, multiply the probabilities if it's followed by, and add the probabilities if it's or. Yeah? Okay, let's have a look at a question. Tara has 8 balls in a box, 5 of the balls are blue and 3 of the balls are red. So we can tell that the probability of having a blue is 5/8 and the probability of it being a red is 3/8. Okay, so 3 out of 8. So we can stick that in there. Okay, Tara takes at random a ball from the box and writes down its color. Then she puts the ball back. So because she puts the ball back, she's replaced it. Okay, so there's still 8 balls in the box and 5 are still blue and 3 are still red. Okay, so when she's picking the second ball, the probabilities stay exactly the same. Okay, so nice and simple there. What's the probability that Tara takes exactly 1 ball of each color from the box? So we can tell, we know we need these two, blue and red, or red and blue. And the fact that I've said or, we know we have to add them. Okay, yeah. And if it helps, just write, oh, there's blue, blue there, and red, red there. Okay, so we need these two. Okay, so the probability of getting a blue is 5/8 followed by, so we times, and then 3/8. And here, of course, it'll be the other way around, 3/8 followed by 5/8. Okay, and then multiplying fractions, you just multiply them straight across. So you've got 15 out of 64, and that's also 15 out of 64. And don't simplify them yet until you add them. So then you've got 30 over 64, which is 15 out of 32, dividing them both by 2. Okay, yeah, so that would be your answer there. All right, okay, be really careful. If they say exactly 1 ball of each color, then you know that it'll either be that one or that one. If they say at least 1 blue, yeah, then you know you have to even include that one there. Okay, all right, so just be really careful with the wordings. They'll try and trick you a bit, but you're not falling for it, right? Okay, let's try the next question. Okay, Max and Lily have 9 bottles of juice in their fridge, 4 bottles of orange juice, 3 bottles of cranberry, and 2 bottles of mango juice. Max takes a bottle at random from the fridge. He puts it back, so it's replace. And then Lily takes a ball from the fridge. Okay, what is the probability that they each take a bottle at the same time of juice? Okay, so here it's Max taking the bottle, and here it's Lily taking the bottle. Okay, now what I don't want you to do is start filling out the whole thing, because as long as you get a feel for it, then you just write down what you need, okay? So it doesn't become so overwhelming. So you can tell the probability of taking an orange juice would be 4/9, cranberry would be 3/9, and mango would be 2/9. Okay, so because we want the same type, each take the same type of juice, we just want the orange or the cranberry. I'll just write the letters. OCM, OCM. So you know we either want the orange and the orange, or the cranberry and the cranberry, or the mango and the mango. Yeah, and because I said or, we're actually going to add all those probabilities. Yeah, so I'm just so well prepared there. Okay, yeah, all right, so don't start writing everything now, especially if it's a replaced, then you know that the probabilities are just going to be the same. Yeah, because he puts it back, so there's still a total of 9, and there's still 4 bottles of orange juice. Okay, so then the probability of the cranberry would be 3 9s, and the probability of the mango would be 2 9s. Okay, and then you just multiply it straight across. So 4 times 4 is 16 out of 81. That would be 3 times 3, which is 9 over 81. This is nice, so denominators are all the same. 2 times 2 is 4. 9 times 9 is 81. And then you just add them. So you've got 16 plus 5 is 25, plus 4 is 29. So you get 29 out of 81. And there's no simplifying there. All right, wasn't that easy? Okay, so don't start getting overwhelmed by writing everything down and then figuring out what you want. Figure out what you want first, and then do the workings of just the ones you want. Okay, yeah, cool. Okay, Max, Robert, and Lily. Oh, we've got Robert now. Okay, have 9 bottles of juice. Max takes a bottle at random from the fridge. He puts it back, so then it's replaced. And Robert takes a bottle and puts it back, and then Lily takes a bottle from the fridge. What is the probability that they each take a bottle of the same type of juice? So again, you can see it can get really complicated. We'll have a branch there, and then a branch there, and then we'd have 3 branches coming out here, and it's also complicated. So let's just do that bit there and figure out what's going to happen to these 2 branches. Okay, so the probability of orange, cranberry, and mango. So we've got our 4 9s there, our 3 9s there, and our 2 9s there. Okay, and here you'd still have OCM, and here you'd have OCM. Okay, and that would still be 4 9s, and that would be 4 9s. So by writing that, can you see I'd just be picking up that one. Yep, because if they're going to take a bottle of the same type, it's only going to be OOO, because once I start off with this branch, you can tell they're not going to be the same, or I can't have OOC or OOM, so I'm just picking that one there. Yeah, and can you tell again, the probabilities are staying exactly the same because they're being replaced. Yeah, so all I'm doing is going 4 9s times 4 9s times 4 9s, and I get 64. Oh, sorry, I'll just put them as 4 cubed, because let's just assume that we're going for the calculator. Yeah, so then it's easier to just show it like that. And here you'd be getting the C followed by the C followed by the C. So here you'd just be going times 3 9s times 3 9s. So here we can just show it as 3 cubed over 9 cubed, because you'd just be going 3 times 3 times 3 over 9 times 9 times 9. Yeah, and the mango would be 2 9s times 2 9s times 2 9s, which would be 2 cubed over 9 cubed. Okay, and then because it's that or that or that, we're adding them, and if you put that all on your calculator, you get 11 over 81 at its simplest answer. All right, yeah, wasn't that easy? Okay, so please do not overwrite. Just figure out what you need to know and then just do those workings. Do not start overwriting and overcomplicating it, because then you won't actually be able to highlight what you need, because you're just filled with so many numbers, and you've got absolutely no stamina for the next exam question. You'll be exhausted. Yeah, all right. Okay, in part 3, we'll consider the situations where the counter or sweet or juice is not replaced. And in the meantime, keep working hard. It's so worth it. And remember, you're in control. Until next time, take care. Bye. See you in part 3.